So the focus of our discussion today is outcome-based, forward-looking at solving issues that we're aware of. To ground ourselves, we wanted to share a few slides to explain the assumptions that we're working with. Soil health has become a focal point in climate change mitigation and adaptation and is the core principle of what is referred to as regenerative agriculture. The microbial life inside the soil is the foundation of organic life. It regulates the water cycle and stores 2 to 3 times more carbon than there is in the atmosphere. It supports plants using photosynthesis to pull carbon and nitrogen into the soil. A teaspoon of soil contains more microbes than there are people on the planet. However, industrial agriculture with tillage and chemicals has degraded the soil microbiome across millions of acres of farmland. Soil naturally holds water in relation to the amount of organic matter it contains. As the soil degrades, water drains from the land, no longer able to hold it. That is impacting the small water cycle. Scientists have documented entire regions drying out, considering the millions of acres of farmland in production. Besides holding capacity, soil health also has dramatic impacts on percolation rates, determining how much rainwater soaks into the ground, affecting flooding and how quickly it runs off, causing erosion. Desertification shifts rain patterns, decreasing rainfall on lower elevations and increasing it in higher elevations. This breaks the small water cycle and allows the more violent large water cycle to predominate, leading to more severe storms with flooding and associated damage. With each 1% increase in organic matter, the soil can hold an additional 20,000 gallons of water per acre. Considering that healthy soil can have a carbon content of 4 and plus %, these are significant volumes of water. With that in mind, what is then required to recarbonize the soil and regenerate the soil microbiome back to health? The recent storm in California showed a difference between healthy soil holding water and preventing runoff. So the 5 core principles of regenerative agriculture are minimize soil disturbance, meaning tilling, maximize crop diversity, keep the soil covered at all times, maintain living roots year-round, and integrate livestock so you get biomass onto the field. It improves soil health, it fosters biodiversity, it promotes economic resilience in farming communities. So the question then is, where do we go from here? Important to note that the planet is on overshoot, using 1.8 times the reproductive capacity of the planet. Yet the global population is expected to grow to 8.6 billion by 2030 and close to 10 billion by 2050. What that looks like is we see 90% of global fish stocks fished beyond their recovery rate, aquifers pumped beyond the recovery rate on the global level, plus the Earth has lost about 1/3 of its arable land already. So as we draw down the ecological capital of the planet with today's 8 billion people, we are at the same time increasing our demand on it, both with population growth and with the demand for higher value foods such as meat and dairy. Organic agriculture offers many benefits. It builds organic matter in the soil, it increases the quality and density of nutrients, it restores biodiversity, retains water and prevents runoff, and importantly, it buys the time needed to shift out of fossil fuels into clean energy. With good coordination and collaboration across the supply chain, the food system has the capacity to act much faster than the energy sector. The transition into a regenerative food system will deeply impact a $1 trillion global industry and will in fact be as impactful to the food system as is the transition to renewable energy. Food is the most basic of needs, and the food system, as it is conceived today, leaves millions of people disenfranchised. In the US, an estimated 24 million people live in food deserts with limited or no access to fresh products. Small and medium-sized farmers and producers have difficulty accessing markets and participating in the economy. Focusing on the repair of soil via regenerative practices brings a range of benefits. Now, as this graphic shows, it reduces the environmental impact using fewer chemical inputs. It increases farm profitability. It improves human health, sequesters carbon out of the atmosphere, and provides economic opportunity for local producers. There is financial support available from both public sources, for example, the Inflation Reduction Act, and significant private investments to support farmers and indeed the entire supply chain from aggregators to processors and retailers. These investments have to transform this important sector of the economy to mitigate and adapt to a changing climate. It would be catastrophic if these funds were to be misallocated. Of equal importance is access to markets in partnership with companies who have shared objectives. Above all, it requires a well-informed public to accept and embrace changes to our menus and shopping habits.